State and prove the Cauchy's theorem for a rectangle. Statement: if the function f of z is a analytical on a rectangle R, then integral del r f of z dz is 0, where del r denotes the boundary curve R dividing R into four congruent rectangles R1, R2, R3, R4 by joining the midpoints of the opposite side by line segments. Now let the boundary of the rectangles be denoted by RK, where k is equal to 1, 2, 3, 4. Now del R is equal to del R1 del R2 plus del R3 plus del R4, so del R4, which is equation 1. The R1, R2, R3, R4, since this point AC, BC, CBD and DAD, since the rectangles over the common sides cancel each other, hence integral del r f z dz is equal to integral del r1 f z dz integral del r to f z dz plus integral del r3 f z dz plus integral r f z dz. It follows from one that the least one of the rectangle R k is equal to 1, 2, 3, 4 must satisfy the condition modulus of integral del r k f z dz is modulus close is greater than of 1 upon 4 modulus starts f of modulus start integral del r k f z dz modulus close is less than equal to 1 upon 4 modulus starts integral del r f z dz modulus close. For otherwise modulus starts integral del r f z dz modulus close is equal to modulus starts sigma k varying from 1 to 4 modulus integral del r k f z dz modulus close is less than equal to sigma k varying from 1 to 4 modulus starts integral del r k f z dz modulus close is less than modulus starts f integral del r f z dz modulus close, which is impossible. Let R1 denotes the one of the rectangle RK for which two holes. If the several RK has this property, the choice shall be made according to the some definite rule. Repeating the above process indefinitely, we obtain a sequence of nested rectangles. R1 contains R contains R1 contains R2 contains so on contains Rn with the property that modulus starts integral del Rn fz dz is greater than equal to 1 upon 4 modulus starts integral del Rn fz dz modulus close is greater than equal to 1 upon 4 square modulus starts del n minus 2 fz dz modulus close is greater than equal to so on is greater than equal to 1 upon 4 raised to power n modulus starts integral del r f z dz modulus close is equation 3. There exists a point z common to all the closed rectangles of the above sequence since fz is analytical on R for the given epsilon is greater than 0. There exists a delta greater than 0 such that modulus z minus z0 modulus star f z minus f z0 upon f of z minus z0 minus f dash z0 modulus close is less than epsilon. That is modulus starts f of z minus f of z0 minus bracket starts z minus z0 f of dash z0 modulus close is less than epsilon. Modulus of z minus z0 for z minus z0 is less than delta. This is equation 4. Let us assume that delta satisfies both the conditions and that Rn is subset of modulus z0 is less than delta. Let us make the following observations. Integral del Rn dz is 0 and integral del Rn z dz is 0, so that integral del Rn f z dz is equal to integral del Rn f z dz minus f z0 integral del Rn dz minus f dash z0 integral del Rn z dz plus z0 f dash z0 integral del Rn dz which is equal to integral Rn square bracket starts f of z minus f z0 minus z minus z0 f dash z0 square bracket close dz which is equation 5. dn denotes the length of the diagonals of Rn. Then z minus Rn implies z minus z0 modulus is less than dn. This is equation 6. Now by 5 we have modulus integral del Rn f of z dz modulus close is less than equal to integral Rn modulus starts f of z minus z0 minus bracket starts z minus z0 f dash z0 modulus close modulus of dz which is less than equal to integral Rn epsilon modulus z minus z0 modulus of dz by 4 which is less than equal to integral del Rn epsilon dn modulus dz by 6 which is equal to epsilon dn ln which is equation 7, where ln denotes the length of the perimeter of Rn. If d and l be the length of the diagonals and the perimeter of the rectangle respectively, then it is clear that dn is equal to 2 raised to minus nd and ln is equal to 2 raised to minus nl. Therefore from 7 we get modulus of integral Rn f of z dz is less than of epsilon dl. This is equation 8. Finally from 3 and 8 we get integral del r modulus of f of z dz is less than epsilon dl. Since epsilon is arbitrary, we have integral del r f of z dz is 0.